Alright, Assalamu alaikum. This is this is Talha bin Nadeem, and I'm here with the third recorded video lecture of the topic mechanical injection systems. So in the last recorded video lecture, we basically studied some of the different arrangements which are most commonly being used in solid injection system: the individual pump and nozzle system, unit injector system, common rail system, and distributor system. And we discussed in quite detail about the individual pump and nozzle system, that each cylinder will have a separate nozzle and a separate pump. Pump may be placed close to the cylinders or may be placed in a form of a cluster as well. Then we studied the second configuration, which is of a unit injector system, and in this type of arrangement, pump and the injector system are being placed in a single housing near each cylinder, as shown in the figure schematic C. Then we studied the common rail system, and in this configuration we have seen that we have a single high pressure pump, and it will pressurize the header, and from that header the fuel would be going into each injectors present in the cylinders. And we said that these arrangements are most commonly being used for multi cylinder IC engines, and in this arrangement the fuel metering is not being controlled by the high pressure pump, but as it was controlled by the high pressure pumps in the previous two arrangement. In this arrangement the fuel metering is being controlled by the injector systems. In fact, the push rod of these injector systems, I have explained these in the last recorded video lecture. Then we have the fourth and the final arrangement, distributor system, which are nowadays most commonly being used in the cars. And in this arrangement we have a single pump and we have a distributor system. In this distributor system, this is the barrel, and this center section is the rotor, and the fuel is when the outlet passage of this inlet is aligned with this outlet port, fuel will be supplied to this cylinder, and when it is aligned with this outlet port, it will be sent to this cylinder. And they are most commonly being used, and it has because it has multiple advantages. The first one was the uniformly distribution is ensured in each cylinders, and they are very less costly as well, since there is only one pump being used, and they are also very easy as far as the maintenance, easy to maintain as well, because there is only one pump which is pressurizing the fuel. Then we studied this comparison table of the various fuel injection system, and in fact I said that that you guys will study this table by yourself, and you will relate the last video tutorial with this table, and you will find the answers, that how this table is being, that what component is doing the metering, how the timing is being done, I have explained all of these part in the last video lecture as well. So you can relate the previous topic with this table. So now we have concluded the four different arrangements which are being used for the mechanical injection system, and as I mentioned earlier that I will explain the components of this mechanical injection system in quite some details. So now we will start the different components of this mechanical injection system. We will discuss four important components of the mechanical injection system. First one is of fuel feed pump, second is of injection pump, third is of the governor system, and fourth one is of fuel injector. We will discuss these four components in quite some details. Starting off with the fuel feed pump, this entire section is of fuel feed pump, and you can see that we have a cam, and this is our camshaft, and you can also see the push rod here. Similarly, this component is of spring. These are the four basic components which are being used to operate to actuate the plunger. And your plunger, this is where your plunger is. Plunger is reciprocating inside this barrel, and these four components, cam, camshaft, pushrod and spring, are responsible for the movement of this plunger. So you can see that when this section of the camshaft is in contact with the push rod, this is the minimum lift position. When this section is in contact with the camshaft, this is the minimum lift position, and your push rod is at the minimum point. Similarly, your plunger is also at the minimum point, and during this minimum lift position there is a suction pressure which is created inside this section, and your inlet valve, this inlet valve will be opened, and the fuel from the suction line will come inside this chamber. It will be filled in this entire section. Okay, this has occurred when the push rod and the plunger is at the minimum lift position, or when this section of the camshaft is in contact with the push rod. The suction is occurring at this point. So when this section of the camshaft has now come in contact with the push rod. So you can see that since this has a larger height, the push rod will move upward, and not only it will move upward, it will also move this plunger in the upward direction as well. And when this plunger has moved in the upward direction, the pressure of the fuel which is trapped inside this cylinder, which is trapped inside this in this passage, has now been pressurized, and the inlet valve has been closed. And because of this pressurized fuel, the outlet valve will be opened, and your fuel will flow through this discharge line because your outlet valve has now been opened. And then it will move towards the other components of your mechanical injection system. So this is how your fuel feed pump is operating. I hope it is clear now. It is not that quite difficult to understand. All you need to understand here is how the camshaft is cam operation has occurred. Cam is basically actuating the plunger. So we can say that it is a spring loaded plunger type pump. Camshaft and push rods are basically actuating the plunger. When we have a minimum lift position, suction is occurring and inlet valve is open and suction is occurring. Fuel is entering into this passage. Now when we have a maximum lift position, plunger is moving upwards and it is pressurizing the fuel, and at the same time the inlet valves have been closed and outlet, or you can say discharge valve, has been opened, and the fuel is then going into the further components of the mechanical injection system. So I hope it is quite clear now that how these fuel feed pumps are basically operating. And now moving forward, here you can see that after fuel feed pump, injector is shown in the schematic. There wouldn't only be injector, there will be the filters and injection pump in between. That's why this is the not discharge line is not going directly into the fuel injector. There will be some injection pump and some filters as well in this section. Now moving forward, the next important component which we will discuss is of the injection pump. And as I have mentioned earlier, the fuel feed pumps are basically low pressurized pump and injection pumps are the high pressure pumps. So injection pumps are basically responsible for pressurizing the fuel to that extent from where the injectors are injecting the fuel into the combustion chamber. They are also responsible for the accurate metering and the correct timely injection of the fuel into the combustion chamber as well. There are two different types of injection pumps which are most commonly being used. First one is jerk type pump, and the second is distributor type pumps. Now we are moving towards the operation of this jerk type pump. Here you can see this is basically the simple operation of the jerk type pump. This is your plunger. This is your inlet passage, and this is your outlet passage. Inlet passage is called feed port and outlet passage is called spill port. So what is happening here is that when this feed port is exposed, the fuel is coming into this chamber, and when the plunger has moved upwards and the inlet port, feed port, is now closed, the fuel which is being trapped inside this chamber will now be compressed. And not only that the fuel will be compressed, but we will have the injector in the upward section as well. We will have the outlet valve in the upward section as well. And when the fuel is being pressurized to that extent that the outlet valve has opened, and then that pressurized fuel is then gone into the injectors, which is the next component of the injector system. What will happen here is that here you can see that when this plunger has come to this point, that this is the helical indentation which is present here. When this spill port is opened, the fuel will now travel from this passage and then into the spill port. Then from spill port into the that spill passages, means no further fuel is required for injection. And here you can see that the plunger is reciprocating up and down. What it is not mentioned here in this diagram is that this plunger is not only reciprocating up and down, but it is also rotating as well, and it is being rotated by using a rack and pinion combination gear mechanism. Rack and pinion gear mechanism. I will show you the video of the jerk type pump as well. So here what here is happening, that I mentioned that fuel is metered by these injection pumps, and it is being metered by this rack and pinion gear mechanism, because for example when this section from which the fuel is being spilled is closer towards the spill port would be exposed much earlier, and that is why the lesser amount of the fuel would go to the injector for injection. And this is what I was explaining earlier, that that duration from where the fuel injection has started, spill port has closed, and to that position, from, let's say this is that position from where the spill port has closed, and this is that position, this is the position where the spill port has opened. This distance is called effective stroke length, which I was saying I will explain in the component section. It does not mean that the plunger is not moving upward as well. Maybe there can be a possibility that plunger is still moving upward, but since the spill port has been opened, there will be no fuel which would be going into the injector, rather the fuel will only be passing through the spill port. So there is a difference between the plunger stroke length and the effective stroke length. Plunger stroke length means that how much the plunger is moving, is reciprocating up and down, And by the word effective stroke length, it means that what is the distance of this plunger movement at which the fuel is being supplied, fuel is being discharged, is being sent to the injectors. By the rotation of this plunger, we can control the effective stroke length. If this helical indentation is, if this groove from which the fuel is being spilled is closer towards the spill port, then we will have the lesser effective stroke length, low values of effective stroke length. But when it is away from the spill port, then we will have higher effective stroke lengths. Okay, now I will show you the video of this jerk type pump.
Fuel injection pump delivers accurately metered quantity of fuel under high pressure. Jerk type injection pump consists of a reciprocating plunger driven by a camshaft.
Now here you can see this is the typical animation. This is the animation of the jerk type plunger pump. This is your cam and this is your camshaft. This is what I was talking about. This movement, this rotatory circulating motion of the cam and camshaft is responsible for the reciprocating motion of the plunger. And this rack mechanism, rack and pinion gear mechanism, is responsible for the rotatory motion of this plunger type pump. And this is the helical indentation which I was explaining. If it exposes the spill port earlier, then lesser amount of the fuel would be going to the injector and we will have the lower values of the effective stroke length. And when we have that position, when the spill port is opened after a long duration, then we will have a greater duration of effective stroke length, and larger amount of the fuel would be going into the combustion chamber, which is required when you are operating your IC engine at the higher loads. Moving forward,
let's have a look at the chief components of this pump. This is the cylinder within which a piston reciprocates. There's an inlet port, a spill port, and an outlet.
now here you can see the plunger is reciprocating in this section. We have the inlet port, spill port, and the outlet port.
The piston fits perfectly within the cylinder.
This is your piston and this is the helical groove indentation which I was talking about.
Notice the helical groove. It plays a crucial role in controlling the quantity of fuel.
And I have explained this part earlier as well, that this helical groove is responsible for controlling that how much amount of the fuel would be injected into the combustion chamber.
The lower part of the piston has a lug, a cam follower, and a disc. This is a sleeve that fits outside the cylinder. It has a tooth part. We'll see why soon. The lug of the piston fits in the groove of the sleeve.
These are the lugs and they are the grooves in the sleeve. The piston is reciprocating up and down and there is a groove inside the sleeve along which it is reciprocating.
This is the whole assembly. The control rack meshes with the tooth portion of the sleeve. It controls the rotation of the sleeve and thus of the piston.
This is your control rack. This straight gear mechanism, and this circular gear, which is a part of a sleeve, is responsible for the rotation of the piston. And by the rotation of this piston, how much amount of a fuel is to be sent into the combustion chamber is being controlled.
This spring presses the cam follower onto the cam surface. A close-up of the cylinder top. A valve closes the outlet of the cylinder. If the fuel pressure within the cylinder is enough to overcome the spring's force, the valve opens and the fuel flows.
Now this is the position of the outlet valve. Fuel is here inside, and when it is being pressurized to that much amount to overcome the spring force, this spring will be compressed and the fuel will flow from here to the outlet passages and will then go into the injectors. And when the fuel pressure inside this container is again lower than the spring forces, then this spring will bring back the valve into its original position and will close the outlet valve. This will happen when the spill port has been opened now. This is the orientation position of the outlet valve. This is the sleeve, the rack, here is the spring and the piston. This is your cam and cam follower, camshaft and cam follower. Reciprocating movement is controlled by the cam and camshaft.
As you can see, the control rack rotates the sleeve and the piston. The orientation of the piston decides the quantity of fuel and effective stroke. When the piston begins, the control rack rotates the sleeve and the piston. The orientation of the piston decides the quantity of fuel and effective stroke.
Now, I hope with this animation it will be quite clear to you that how this control rack is controlling the rotatory motion of the piston and how it is going to regulate, how it is going to control the amount of a fuel which is to be sent. For example, when the spill port is opened at this position here, we will have a lesser stroke length, but when the spill port is opened at this position, we will have a larger stroke length and the greater amount of fuel would be sent through the outlet valve.
When the piston begins to move up, at first the fuel can exit through the spill port. There's no pressure buildup and the valve remains closed.
When the piston is downward, fuel is coming in. Some fuel will also pass through the spill port as well.
Once the spill port is blocked, the fuel is trapped. As the piston rises, pressure builds up, which exerts a force on the valve. Ultimately, the valve opens and high pressure fuel is delivered to the injector.
Now you can see that now the fuel has been trapped inside this chamber. Well, as the plunger moves upward, it is pressurizing the fuel, and when it has pressurized the fuel, the outlet valve will open and fuel will go from the outlet valve to the fuel injector.
As the piston rises, the spill port is uncovered again. Pressure drops and the valve closes. The duration for which the valve is open in each stroke is known as the effective stroke.
Now here you can see now the spill port has been exposed and the pressurized fuel which was present here, some of that pressurized fuel will pass through this spill passage, and now the pressure inside this chamber has been decreased and the outlet valve will be closed.
Pressure drops and the valve closes. The duration for which the valve is open in each stroke is known as the effective stroke.
It has also explained the concept of the effective stroke, that for the duration which the outlet valve is opened, is called the effective stroke length, and here you can see that plunger has not reached to the maximum position, but the outlet valve has been opened. So there's a difference between the stroke length of the plunger and the effective stroke length of the plunger. By the word stroke length, it means that the plunger is moving from bottom dead center to the top dead center, but by the word effective stroke length, it means that the duration for which the outlet valve has been opened and the fuel is being supplied to the fuel injector, and it is being controlled by this helical indentation on this of the piston.
Again, pressure drops and the valve closes. The duration for which the spill port is open and the valve is closed.
Now here you can see we have another arrangement. Now the piston has been rotated by using the rack and pinion mechanism, and in this arrangement you can see that the larger portion of this helical indentation is near the spill port. So now the stroke length will be higher and there will be a larger duration for which the fuel will be supplied from this outlet passages.
The piston rises, the spill port is covered, and the valve opens due to the pressure. The piston rises further, the spill port is still closed. Notice that the valve remains open longer in this case, that is, a longer effective stroke. Once the spill port opens, the valve closes back down.
So I hope it is quite clear in this video animation of the jerk type pump. I will share this video with you guys as well. What we can conclude it by saying that the reciprocating motion of the piston is being controlled, actuated by the cam and camshaft mechanism, while the rotatory motion, circulatory motion of this rotatory motion of the plunger is being controlled by the rack and pinion mechanism. And by controlling this rotatory motion, the amount of fuel which has to be injected into the combustion chamber is being controlled. So it consists of a reciprocating plunger inside a barrel. This is your plunger, and outside section, this is your barrel. This plunger is being driven by a camshaft. Near the port A, fuel is always available under relatively low pressure. This is the inlet passage, and the axial movement of this plunger is being controlled by the camshafts, while the rotational movement is being controlled by this rack and pinion mechanism. When the plunger is below port A, this inlet port, fuel would be coming in and some of the fuel would be passing through the spill port as well. As the plunger rises, the port A is closed and now the fuel is trapped inside this chamber and will be pressurized until the spill port has been exposed. Now in this arrangement you can see that we have rotated the rack mechanism, and now the spill this helical indentation, this spill port will be exposed after some duration, after quite some time. Here you can see that it is also mentioned the effective stroke as well. This is that point from which the outlet valve has been opened and fuel is being supplied from the outlet valves, and it is that point when the spill port has been exposed and now the fuel is being passed through these spill ports and not going from the outlet discharge valve. So in this arrangement we can see that the lesser portion of this is exposed, and we have a smaller stroke length in this case. And how this arrangement has been occurred, this is this has we can achieve this position orientation by operating this rack and pinion mechanism. So I hope we have a better understanding regarding the fuel feed pumps and the jerk type pumps as well. So I hope you guys have understood so far. Then now moving towards the next to the second type of the fuel injection pump, and it is of the distributor type pump. Here you can see the schematic of the distributor type fuel injection pump. I will explain the working of this distributor type fuel injection pump. Here you can see that we have these are the two plungers, and these plungers would be going against each other and then coming towards each other. They would be reciprocating in a horizontal direction. When they are moving away from each other, fuel would be taken into between the distance between them, and when they are coming towards each other, fuel would be pressurized and then will go to the outlet passages. Here you can see that if we look at the top view of this this figure, this is the inlet passage from which the fuel would be coming in, and when this inlet port is aligned with the inlet passage of the rotor, these are rotor, and this outlet section is called barrel. When this inlet port is aligned with the inlet passage of the rotor, the fuel has come into this longitudinal passage which is present here. When the plungers have moved against each other, this will happen at the same time. Plungers are moving against each other, and the inlet port and the inlet passage of the rotor has aligned with each other, and the fuel will flow into this longitudinal passage. Now these plungers will move towards each other, and when they are moving towards each other, they would be pressurizing the fuel. And similarly, this rotor is now rotating. The inlet passage and the inlet port will now be misaligned. No more fuel is coming into this longitudinal passage, and it has rotated to that much that this outlet passage has now been aligned with the outlet port, and the fuel has been pressurized to that extent which is required to the fuel injector. Then it will pass from this longitudinal passage into the outlet and then into the fuel injector. This is how the distributor type pumps usually operates. For a single cylinder it is quite easy to understand, but for the multi-cylinder you can see here that we have number of outlet passages. We have 6 outlet passages. It means that this distributor system is for the 6-cylinder pump, means we have 6 outlets. When when it has rotated and this outlet passage has come aligned with this first cylinder, fuel is injected in this cylinder. Now it has further rotated and it has aligned with this cylinder. Now fuel is injected in this cylinder. Now it has further rotated and this radial hole has aligned with the third passage. The fuel will be injected into the third cylinder, and then to the fourth, fifth and sixth, and then this cycle will keep going on. This is how distributor type pumps operate for the for multi-cylinder engines. Now and similarly that goes for the inlet passages as well. Now I will show you the video of the distributor type pump. To video animation of the distributor type pump, it will also clear the visualization of these sorts of a pump.
The distributor type fuel injection pump has a single pumping element, and the fuel is distributed to each cylinder by means of a rotor. It is small in size and lightweight.
So it has mentioned some of the advantages, that these fuel pumps are smaller in size and they are lightweight, and there is only one pumping element which is controlling the amount of a fuel. So the equal amount of a fuel would be going into the if we have a multi-cylinder engine. We will look at some of the basic components of the distributor type pumps now.
Let's have a look at the various parts. There is a central longitudinal cavity in the rotor and a pair of radial holes at different heights. One hole is for fuel inlet and other for fuel outlet.
There you can see that we have a longitudinal passage, or you can say a longitudinal cavity, where the fuel will be stored, and when this inlet passage is aligned with the inlet port, fuel will come in, and when this outlet passage is aligned with the outlet port, fuel will go out. This is what the cross section view of the rotor will look like, which I have also explained in this slide as well. This is the cross sectional view of the rotor.
The fuel is drawn in or forced out of the cavity as per the movement of the plungers. The cam ring controls the movement of the plungers via a roller and a bush at each end. Over the rotor there is the movement of the plungers.
There you can see we have a spring and a plunger.
The cam ring controls the movement of the plungers via a roller and a bush.
These are rollers and this is the bush. These are plunger and we have a spring in between. When it is rotating across the cam ring, when this has come in contact with this section, the compression would be occurring, or you can say the fuel would be pressurizing, and when it again comes towards this section, suction pressure would be created
at each end. Over the rotor there is a stator that contains inlet and outlet ports for the fuel.
Barrel
the plungers via a roller and a bush at each end.
Barrel is the stator part, and we will have the inlet port and the outlet port in the barrel.
In the rotor there is a stator that contains inlet and outlet ports for the fuel.
This is the spring, there are the plungers, there comes the bush and the rollers. This is the cam ring.
As the inlet passage of the rotor aligns with the inlet port, the plungers move out, drawing fuel into the central cavity.
Now you can see at this point the suction pressure has been created and the fuel would be taken in for the and fuel will be taken in, and
When the outlet passage aligns with the outlet port, the plungers move inward, pushing out fuel from the cavity.
here you can see not only that the plungers are moving away from each other and the suction pressure has been created, the inlet port has also come in align with the inlet passage. Inlet passage is on the rotator and inlet port is on the stator part. They have been aligned and the fuel will come from inlet port into the inlet passage and then into the longitudinal section of the rotor. Here now plungers are coming towards each other and fuel is being pressurized, and outlet port is being aligned with the outlet passage at this point, and the pressurized fuel which is present in the longitudinal section will now pass through this outlet passage of the rotor towards the outlet port on the stator, or you can say barrel, then into the fuel injector.
Now, consider an injection pump for 4-cylinder engine. There are 4 inlet passages to intake fuel 4 times and 4 outlet ports for the 4 cylinders.
The first animation was regarding the single cylinder pump. Now if we have usually we have a multi-cylinder pump. This is the schematic, this is the arrangement, this is the animation for the 2-cylinder for the 4-cylinder engine. Here you can see that we have multiple inlet passages, 4 inlet passages, and on the top we can see that we have 4 outlet ports, one each going towards one cylinder. Here you can see inlet is occurring because inlet passage is being aligned with the inlet port. Now on the top you can see that pressurized fuel and the outlet passage and the outlet port is being aligned, and the fuel would be going into this cylinder. Now at the bottom you can see that fuel is coming in. Fuel is coming into this longitudinal section, and there is no outlet port which is being aligned with the outlet passage. So fuel is just present at the longitudinal section, and now here you can see that the plunger will be coming towards each other and would be pressurizing the fuel. Now the outlet passage and the outlet port has been aligned with this cylinder. Previously it was aligned with this cylinder. Now it is aligned with the second cylinder. Now the fuel would be going into the second cylinder. Now the inlet passage has been aligned, fuel is coming in, plungers are coming towards each other, it is pressurized, and then fuel is being supplied towards the third cylinder. So this is how 4-cylinder engine arrangement would be. I have shown you the 6-cylinder arrangement in the slides as well. Distributor systems are most commonly being used in our IC engines. They have a very simple arrangement. We only have a single pump, same amount of fuel would be supplied to each cylinders. They are not complex, lesser in cost, they have lower weights. That's why they have very high advantages, and most of the IC engines incorporate the distributor type fuel injection pumps. So this pump has a single pumping element. The fuel is distributed to each cylinder by means of a rotor. Central longitudinal passage in the rotor, and there are also 2 sets of radial holes, one for the inlet and other for the outlet. and they are located at the different heights. Inlet are located usually at the top, at the bottom, and outlet are located usually at the top. One set is connected to the pump inlet via central passage, whereas the second set is connected to the delivery lines leading to the injectors of the various cylinders. The fuel is drawn into the central rotor from the inlet port when the pump plunger moves away from each other. When they are moved away from each other, fuel is taken in. When they are coming towards each other, fuel is being delivered to the outlet port. The main advantages are they are small in size and light in weight. So this concludes with this video tutorial. I know it was a lengthy video tutorial, and there were a lot of things which needed to be understood, and I have tried my best to explain the most of the part. In case you have any question, you can always ask me. Just note down your question. You can ask me in the online session as well, and if someone doesn't get a chance to ask the question in the online session, you can ask me through the WhatsApp group or in the Google Classroom as well. So in the next class we will start off with the governor and the fuel injector topic. Till then, Allah Hafiz, and just make sure that you watch these videos and understand the concepts of these pumps, of these main components, and how these injection systems are operating. Okay, till the next video, Allah Hafiz.